So hello everyone, my name is Ted. I'm team lead of the FuelCellDrone, and here's my sub-team lead for the electric team, Jeff, and here is Jacob from the electric team, and those two, Dongcheng and Kim, are my mechanical team members. So a brief background for the project. Basically, fuel cell has become one of the promising replacements for the fossil fuel. And the reason why we are doing this project is we really want to learn the real life application for fuel cells. Like we want to apply fuel cell technology into daily life. And this one starts with a fuel cell drone, which if we are able to apply fuel cell into a drone, we're probably able to apply this technology in other devices that we are dealing with daily. And a little bit information about fuel cell. Fuel cell is like a 100% clear energy. The emission produced by fuel cell is like almost zero, or regardless, you can just like ignore the emissions. And the fuel cell we are dealing with in the project is basically the prime fuel cell, which has a low operating temperature, about 80 Celsius. And one good thing about this one is at the station, like the fuel cell station, fuel cell pack for this one is pretty small, so which we can install those things into like either vehicle or drones, like small components. So what we did for the fall quarter is basically research on fuel cell operation, pick the fuel cell that we're going to use, and then build the testing bed. Like we built several testing beds last quarter, but none of them doing well, so we just like switched method to we built two testing beds, and I will talk, like my mechanical team and the electric team will talk about this later. And then the goal for the project is still same as last quarter. We are going to design and build a helicopter drone that is powered by the fuel cell battery and able to carry 5 kilograms. The 5 kilogram right here basically means that after install on the components of the drone, like the fuel cell, the gas tank, everything, and including the body of the drone, we can still like carry 5 kilogram load in order to fly. And some objective for this quarter, still we're doing research on fuel cell operation. We just picked the power supply, like the fuel cell that we're going to use last week, and then we still start, like our mechanical team are still studying the structures for drone and constructions, trying to develop the drone, the structure of the drone to make everything as light as possible. And we have the trade-off study for power supplies and of other electric stuff. The reason why we're using a DC power supply right here is because fuel cell is pretty expensive, and we want to use the same power DC power supply to test the performance of the testing bed first, and then we're actually going to place a purchase request on the fuel cell, so we just don't waste the money on unnecessary stuff.
The requirements for our project still the same as the last quarter. The drone should be powered by the fuel cell battery, and as Ted said, we're gonna have a 5 kilogram payload only, except for the block weight of the drone itself. And for flight times, it's gonna be 10 minutes. But due to the characteristic of the fuel cell, it is easy for us to expand the flight time because theoretically we can expand the gas tank. So it is easier, but the challenge for us is to overcome the power to weight ratio. The last quarter we used the 12-volt electronic system, but we overestimate the convert rate and the charge rate for our battery, so it can barely take off with the all up weight with 3 kilograms. So for this quarter, we're gonna change the 12-volt system to the 24-volt system.
And here's a spreadsheet for the design requirements for the project. So as we know that we are going to build a fuel cell power drone. We're trying to analyze like which way is the lowest cost and like reasonable durability. At least 10 minutes, that's a requirement. And also the reasonable range right here is basically like from the floor, as a radius of 50 meters. Like that's the ideal condition that we want to be. And also we want to make the user friendly. That's why we say easy to use. Like keep everything simple as a good engineering design. Also the eco-friendly, which is like we're using the fuel cell and we're trying to lessen noise pollution. Because like some of the fuel cell itself, I know most of fuel cell it doesn't produce any of the noise, but some of them the sound is pretty loud, and also the motor powered by the fuel cell is very loud too. So we are trying to think about some way to reduce of those sound, and also like for the energy consideration, we're trying to save on it. Because like the budget is very limited, so we're trying to use every single energy onto the right place, not to waste any of the power. So next, the organization, I'll pass to my electric team lead, Jeff, and he will explain the structure of our team.
We currently have 13 members in our team, and we have three sub-teams. They are mechanical, electrical, and control, and document. For mechanical team, they like design and build the reference drone and the testing bed. And the electrical team where I lead, we're gonna design the circuits, research on the converter, and we're gonna build up the whole circuits and assemble the testing bed. For document team, they are like document the daily meeting, a weekly meeting, and that's it.
All right, thank you, Jeff. So right now we're coming to the timeline. As you can tell right here, like from last quarter, we are more about in learning process, which we're trying to learn everything related to fuel cell or drone. So we brought the reference drone and did a lot of case study. And this quarter until now, we're like more focused on real hand experience. Like we reserve the working station in ET, and my mechanical team are working on the testing bed and trying to develop the testing bed every single week. So, for the next quarter, I'm trying to think of, what I'm trying to do is to actually install the fuel cell, like having a complete data and install the actual fuel cell into the drone. So that's on the thing we are going to decide for right now. And if there's any update, we probably will be updating those things in the next peer review. And right now, here is the progress on our testing bed, and I will pass to my mechanical team member, Kim.
For purpose to make the testing bed is we got to collect the actual data. So we make the 12-inch body and 14-inch just the arms. That's why, because we just calculate the lift force and then another data, just calculate. So we need to have the actual data. That's why we made the testing bed. And then this is our testing bed. And then we made it MDF wood. And then this total weight is just the 1.18 kilogram. That is similar to our prototype drone. So that's why we made the MDF wood.
Just some add-ons to the electrical. So this set of the electronics requires a power of 1,000 watts. And right now we are just using, it's like, I think it runs at 12 volts and 40 amps. And the maximum power is like 2,000, it's like 2,000, yeah, 1,000 watts. And right now we are just using a DC power supply to power up this one, and trying to switch around the current and the voltage, and to figure out the best way to power up the testing bed itself. And right now it's electronic, and I will pass to my electronic team's Jacob. He will do it.
The task for our team for this quarter is divided into two parts. The first is we're gonna research and purchase the whole new 24 volt system. It's gonna have much more powerful lift force. And the other one is we're gonna move the 20 volt power system to the testing bed. And for the power input for testing bed, we have two ways to control it. The first is we directly buy the programmable power supply, but that's out of our budget, so we're gonna still use the flight controller to control it. And for the payload testing, we're gonna directly put some payload. Yeah.
Alright, thank you, Jeff. And now Jacob is going to go over more details on the electronics.
Here's some tasks we have done
1 minute.
in this quarter. So pretty much we first designed the drone's electronic schematics for both the testing bed and then drone systems. And then we did a lot of research, and then for those research, we purchased the new electronic parts for our drones. And then after we got all our electronic parts, we assembled the new circuits and then ensured the wires all function good. And then also we done a lot of soldering, like soldering with different parts, like burner parts and T-brass for the picture shows for the EC connection. Then the last things we have done is calibrate the new flight control with the new 24 voltage, and then with the new one. That's the things we have done.
Alright, just a wrap up. So for the future, our team is getting in touch with a lab party named HRL in Malibu, and we probably have some collaborations next quarter. Like we are going to exchange some members. We will send some members to there doing internship, and they probably send some researcher to us and help us doing this drone. So the fuel cell drone is really a great application to the fuel cell technology, and yeah, we are trying to figure out those applications that make it into real life. And here's our budget, which we have the euro funding is 1,200, and right now we spend around 800 for the material, power supply, and the reference drone. Thank you for listening, and is there any question?